Alright, so this is Physics 20, Lesson 1.1, talking about the language of motion. And the first thing we're going to do here is take a look at the difference between scalar and vector quantities. Now, a scalar quantity is a measurement with magnitude only. Where vector quantities are measurements with both direction and magnitude. Measurements with both direction and magnitude. Now, the word magnitude means how much. For example, when we talk about this, temperature would be considered a magnitude. Temperature, we say, is like 20 degrees or 50 degrees Celsius. We don't say it has 50 degrees Celsius going west. That would be something like velocity. Velocity, we would say, is going like 50 kilometers per hour west. One of the easy ways to remember that is with this little cartoon from Despicable Me.
Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Now, when we talk about distance, this is actually a scalar quantity. It's a scalar quantity. It is the length of path from one position to another. Where displacement is the straight line change in position. So let's just say, for example, we are at point A, we want to get to point B, and in getting from point A to point B, we travel this way. The distance traveled will be the total length of the purple line. The displacement, however, is the straight distance from A to B. It's a straight line distance, and so the displacement, which we've got in red, is less, has less magnitude than the distance. This might be, let's say, 10 centimeters. But the displacement is probably only sitting at around 7 centimeters. But it's 7 centimeters going to a little bit right and up because it has direction as well as magnitude. Often, we use conventions that have a positive and a negative. And within that, we might say on a plane going north and south, we would typically call south negative and north positive. That would be within the north-south plane. We also might use it with west as being negative and an east being positive. And that would be in the east-west plane. Up is something we would call negative, where down is something we would be calling, down we would call negative, up we'd call positive, and that would be in the up-down plane. We also can have a right, which we'll call positive, and a left plane, which we'll call negative. Now, these conventions are used in a 1D plane. If we have things going in multiple planes, we got two-dimensional motion instead of one-dimensional motion, it gets a little bit more complicated. We will take a look at that, but essentially what we do is we treat each plane individually and then combine them at the end. Many of the symbols on your formula sheet have little arrows above them. For example, we've got V is d over t, and you've got these little arrows over some of them. Where you've got those little arrows, that means it is a vector quantity. It's a vector quantity, which therefore requires both magnitude and direction. I'm going to put in a little oh yeah there. So let's take a look at a couple of examples. The first one, we've got a man walking east 275 meters, turns around and walks 425 meters west. What is the distance traveled by the man? Well, if we take a look at that distance, he's traveling 275 meters and 425 meters. That is a total of 700 meters. But if we talk about the displacement of the man, he started here, he went 275 meters east, he went 425 meters west, so his displacement is actually only from here to here. We can write that out with a displacement of plus 275, and we're adding to that negative 425. The negative because it's going west. Our answer here winds up being negative 150 meters, which we would also could write it as 150 meters west, putting the direction in square brackets after the magnitude. Within the context of the question, the negative automatically would assume west. We've used normal conventions here. Sometimes we have people who will actually flip that or whatnot, but by convention, we would call west negative. Let's take a look at problem number 2. Girl takes a girl for a walk around the block. We want to know the distance. Notice that is a scalar quantity. We only want to know the distance traveled. Well, we don't know which corner she's at. Let's just assume it's here. She's going all the way around. So we've got 115 plus 125 plus 115 plus 125 as she goes around the block. And when you add all that up, you get 480 meters traveled. No direction needed. But if we want to know the displacement, well, she starts here at point A. She actually ends also at point A. And so what that means is the displacement, meaning a vector quantity, is actually 0 meters. There is no overall change in position. So we do have a few homework questions. Now, whenever we're doing questions, there are 4 things that we're going to need to be communicating. The first one is the actual answer to the question. Now, that seems obvious, but it's something that can't be forgotten. But we're also looking for a few other things. The logic for finding your answer. Now, this could include showing work. But not all question has worked, such as 2b that we had up here. But the logic is right here. Use of proper physics convention, this would include things such as units, arrows over formulas, etc. And your answer should be rounded to the same number of digits as the question given. Right? That deals with what we talked about in terms of significant digits. But here's a key thing. We only round at the final answer. And this is especially important for numeric response questions. They will assume that the rounding happens at the end, not along each step, because otherwise you're rounding rounded numbers and eventually you can get things that are a little bit less accurate. So, that being said, thanks for watching, and if you got any questions, let me know.